And this is being recorded as a YouTube video, so I'll actually just post a YouTube link to it. It means it's not going to be pretty and be broken up into chapters like the videos on eClass are. That software I no longer have. I have it, but it doesn't work with Windows 10, which is what I have running on this computer now, unfortunately. Okay, the last section in this chapter, which you guys might want to know, is this is going to be 9 sections, and I think we only have around 30 homework assignments for the whole month, so you're over a quarter of the way done. Happy about that? Yes. This one's actually not bad in comparison to the last one that we just did. It begins on page, let me find it for you. In your textbook, if you're following along on your ebook, it's page 84. We're talking about inverse functions today. Finding inverse functions is going to be relatively straightforward, very basic algebraic steps. The definitions in the first few motivational examples are going to look a little strange. Don't worry about that. We'll get to the easy part. So the definition says let f and g be 2 functions so that f of g of x equals to x and g of f of x equals to x. In other words, this is my f composed of g, and this is g composed of f. This is under these conditions, the function g is the inverse of the function f. The function g is denoted by f inverse. So in other words, we say g is equal to f inverse. And the domain of f must be equal to the range of f inverse. And the range of f is equal to the domain of f inverse. Let's see if I can write that a little better. This is a test question. Memorize it. I'm going to ask you. It's going to be one or the other. It's been on every test for the last 3 or 4 years. And it'll be fill in the blank. It'll say something like the domain of f equals, and you have to fill in the last half, or the range of f equals, or the domain of f inverse equals. Know that relationship. This is a test question. Memorize it. It's your easy test question. You have to have an easy test question. Okay, so in other words, what is this saying? You guys are used to this notation. If I say 1 over x, you know that that's equal to x to the minus 1, right? Let me show you why. 1 over x times x is equal to what? 1, right? If you did 1/2 times 2, you get 1, right? So I would say that 1/2 is equal to 2 to the minus 1. That notation we're used to. We think of it as saying, write it as a fraction. When we see that minus in the exponent, we think of a fraction. Well, that's because we're thinking of multiplicative inverses. We're stretching that, and now we're going to talk about the inverse of a function. The inverse of a function is not equal to 1 over f. So f inverse is not equal to 1 over f, with the exception of f of x equal to x. So f inverse is what you do to f so that your answer is just going to be x, the identity function. Okay? So we're trying to figure out what do we do to f so that our answer is always just x. That's our goal. Turns out all we're going to do is interchange x and y. The inverse function just interchanges x and y. So let's see why. Suppose you have the relation f is going to be, and I'm going to write it out, 1, 2, minus 1, 1, 0, 3, 2, 4. This is also a function. Each x value only goes to one y value, so it's going to be a function. And what I want to know is if I make g be the relation 2, 1, 1 minus 1, 3, 0, and 4, 2, What is f composed of g? Yeah, so let's start with, this is f of g of x. So I'm going to start with 2, and where does 2 go to under g? 2 goes to 1. Go up here to f, where does 1 go to? 2. So it takes 2 to 2. Start with the next one. Under g, 1 goes to a minus 1. Where does minus 1 go to for f? 1. For the next one, I start at 3. 3 goes to 0, and where does 0 go to? 3. And for the last one, 4 goes to 2, and where does 2 go to? 4. Notice each of these is the same value. It's 2, 2, 1, 1, 3, 3, 4, 4. This is the same function as the identity function. It gives back the same thing you plug in. You put in an apple, it gives you an apple. You put in an orange, it gives you an orange. It's an identity function. Doesn't change anything. So that is telling you that f inverse is the same thing as g. Now, you say, okay, it worked that way for f composed of g. Let's do g composed of f. So I have to start with the f function. F takes 1 to where? And then g takes 2 to 1. Start with minus 1. F takes minus 1 to 1. And where does g take 1 to? Minus 1. Start with 0. F takes 0 to 3. Where does g take 3 to? 0. And then the last one, f takes 2 to 4. Where does g take 4 to? 2. I got off of it. There we go. Compare these. Well, first of all, let's look at this. Is the x and the y values the same all the way through? Yeah, so that tells us that this is the identity. It doesn't change anything. So that says g inverse is equal to f, or I can write it the same way I did before. F inverse is equal to g. They're the same. They're inverses of each other. Compare these two identity function representations. Do they have the same numbers in them? Up here I have 2 to 2. Do I have 2 to 2 down here? Yeah, it's the last one. I have 1 to 1. Do I have 1 to 1 down here? Yeah. I have a minus 1 to minus 1. Do we have minus 1 to minus 1 up here? No. I have a 3 to 3. Do I have a 3 to 3 down here? No. How about 4 to 4? No, they're not exactly the same functions. They don't have the same sets in them. But they're both identity functions because they take the same value to the same value. Okay. So this is also an identity. The functions might not look the same, but they're the same function because they don't have any differences. Any questions on that so far? So what is the difference up here between f and g? If this is the x and this is the y, I have a 1, 2 up here. What do I have down here? 2, 1. This would be like y, comma, x. I changed the order. So g is simply interchanging x and y in f. That's how you get your inverse function. Interchange x and y, that gives you the inverse function. That is what we have on our remark. Note that the inverse function f inverse just interchanges the x and y values of the function f. This is the same as reflecting the function f across the line y equals to x. Let's see that. Suppose you have the point, I'll say this is going to be 0, 1. And suppose you have the point 1, let's go with 4. And we have this parabola going up like this. If we have our line y equals to x, this would have the 0.11 on it right here, and you'd have 0, 0 on it. If you interchange your x and y, then that 0.01 becomes a 0.10. That 0.14 would become what? 41. And so if I draw my picture, it's going to look something like that. It's a reflection across the line y equals to x. That is also a test question. Learn it. That's a test question. It's another easy test question. F inverse is a reflection of f across the line y equals to x. Okay. Let's look at some examples. Which of the functions below is the inverse of the function f of x equals to 5 over x minus 2? Well, I know for them to be inverses that the function composition has to be equal to the identity function. So let's do f composed of g. If I do f composed of g, that means I'm plugging in the g of x for the f. So I have 5 over something minus 2, and now I have to plug in the g for that something, which is x minus 2 over 5. Now we just do our basic arithmetic here, algebra. I have a fraction in my denominator, so let me write that as a 2 over 1, and let's get a common denominator. What is my common denominator going to be? 5. So I have x minus 2 over 5 minus, this is going to be times 5 over 5, so that's going to be a 10 over 5. Combine that into one fraction in the denominator. I have an x minus 2 minus 10, all divided by 5. What is minus 2 minus 10? X minus 12 over 5. Now, I have this fraction in the denominator, so I have to flip it upside down and multiply by it. So multiply straight across the numerator, you get 25. Across the denominator, you get over x minus 12. Is that equal to x? I can't simplify it anymore. Is that equal to x? So this one is not an inverse. Let's look at the second one. Again, I'm going to do f composed of g. So this is f of g of x. So I have 5 over something minus 2, and here's the something. It's question. Oh, yes, yes, yes. There's an h there. You are so right. Now, what can I do? I have 5 over x plus 2. Let me write this minus 2 on the same level. What is plus 2 minus 2? 0. So 5 over x. What do we do with that fraction in the denominator? Flip it and multiply by it. 5 over 1 times x over 5. The 5s are going to cancel. That leaves you an x over 1, which is the same thing as an x. Did you end up with x? So h equals to f inverse. H of x is the inverse function. Okay, that one is the inverse function. Any questions on that? You have your first few homework problems are going to ask you to verify which ones are the inverse. Determine which is the inverse. You're going to have three or four, is it 2 or 3? I forget. For each question, you'll have one function, determine which one's the inverse. So you have to verify it. You have to check the function composition for it. Now, example 4 is going to say sketch the graphs of the inverse functions f of x equal to x squared and f inverse of x equal to the square root of x. Notice it's giving me the restriction. It just wants this done for x bigger than or equal to 0. First of all, do we believe that these functions are inverse functions? If I plug in f inverse, the square root of x, into x squared, I have the square root of x squared, which is equal to what? X. So they are inverses. Now, tell me about the graph for x squared. What is that shape? Parabola, opening up. And I'm just going to graph the right-hand side of it because they only want it graphed for bigger than 1. I mean bigger than 0. Here's 1. Here's 1. It goes through 0, 0, and 1, 1. How about the square root of x? That looks like a butterfly. The square root of 1 is 1. It goes through that value also. Let me make one of these red so that we can see the difference. Now what we want to do is look at the line y equals to x. The line y equals to x actually goes through both of those points. So notice my inverse function crosses my line y equals to x, actually in 2 points. And the regular function does as well. Where the inverse function and the regular function cross will lie on that line y equals to x. When they intersect, they're going to lie on that line y equals to x. Notice all I need to know is how to graph one of them, because I can get the graph for the other one by reflecting it across the line y equals to x. So I only have to know how to graph one of them. And that saves us time. Okay, they say, and then show that. So you just draw your line y equals to x to show that, and you can see it's a reflection across it. If you can sketch well. Mine doesn't look well reflected, but I'm not an artist, so I always tell people there's a reason I'm a mathematician, because I failed art in elementary school. I didn't exactly fail it, but let's just say that it was not stellar grades. Everybody has to take art in elementary school. They want you to draw all these pretty pictures, and all of my pictures look like stick figures. It doesn't matter what I'm trying to draw. It looks like a stick figure. So I am not an artist. And when I get into Calc 2, I have to start sketching things, different, harder shapes than what we have to sketch here in Precalculus. And they don't work. I mean, we're talking, you get up into some 3-dimensional things, and I can't sketch in 2 dimensions. Yeah. Doesn't work. But usually there's 3 or 4 students in every class who are artists. It's like, oh, can I take a picture? And I'll just use your picture. Okay. You guys get to try one. Sketch the graphs of the inverse functions f of x equal x cubed and the cube root of x. You do not have a restriction for yours. You sketch it for all values of x, both positive and negative. I'll show you why in a little bit. I had the restriction. But you guys should be able to sketch this for all values. You're sketching this function right here and this function right here, just like I did up here. You're just sketching them on the graph, and then draw your line y equals to x across it. That's what you're doing. If you don't remember the shapes of them, section 1.6 notes on E5 has the shapes. Mm-hmm.
all you have to do is get the cubic rights. You just have to know this one. You know those 3 points. That has to be on the line plus tax, right? And the line plus tax back. You go to the question on line plus tax. That's all you have to do. Once you get the x cubed graph, guys, reflect that graph across your line y equals to x. And you'll get your cube of x. Very close, actually. Just a little bit too much up. Oh, yeah. Very close. So let's keep the graph up and down a bit. Let's draw on the x. So you know that this is 1, this is 1. You can get a reflection across the line, the x-axis, and then plus this. So everything goes up here, goes down, but it stays in the same place. So yes, so draw this line, draw this. And this is everything is just everything else. So we have this last bit. Is that finished? Maybe before we go on this line on it. So this is a little bit more like well, I know that if you keep 1 and get 1, then you get 0. You minus 1, you get minus 1. And then we have to it comes up now. This is like you have it. Now, if you look at this time, this is along the line, just like that. So everything that's up here is going to go down here below.
So what would be this?
No, that's the square root of x. The cube root of x looks like the square root of x. Hey guys, let's do this together. We're going to be doing it for everybody.
Okay. First things first. Let's sketch our cube root of x. I'm sorry, our cube x, our cubic function. This is not working well. Let's see. I put my scale really big. There we go. There's our little S curve through there. Now I'm going to sort of sketch my line y equals to x, and then reflect that across your line y equals to x. So if it's here in this quadrant, this area right here, it now has to go right here. Think about folding it across your line y equals to x. And so what that's going to do is I'm going to have this coming up like this in that region. And then it has to, what was below goes above. and it's going to look like that for the tails. Did that make sense? Draw the function you do know, reflect it across the line y equals to x to get the other function. So then this becomes the cube root of x. So now you know that odd roots look like S curves that are lying on their sides in comparison to the cubic function. That's what's happening on that. So do we all have that now on our papers? We got the first question right. It's going to make it a lot easier for me to grade when they're all right. They've all been really correct. I've been really pleased, by the way. You guys are doing great this semester, or whatever we call the summer session. I haven't had a test so far, but everybody's got like 100%. It's awesome. It's awesome. So there's a pretty picture of what I was trying to show you guys that I sketched it for. Yeah, you can see that it's just a reflection across that line y equals to x. Now, how do you know when you can find inverse functions? Most of what we've been doing up to now has been really straightforward. You know, can you sketch something on a graph? We're getting ready to actually do the algebra, which is the meat of this section. So the horizontal line test for inverse functions. A function f has an inverse function if and only if no horizontal line intersects the graph of f at more than one point. The same thing is said for one-to-one. That horizontal line test is the same for one-to-one. One-to-one means each x value gets mapped to only one y value. Let me give you some pictures here. Our cubic function that we were just looking at looks something like this. If you draw a horizontal line through this at any place you want, does it cross more than once? No. So this one is one-to-one. I don't like writing the words one-to-one. So one-to-one right here is equal to 1-1. That's what it means, one-to-one. This one is one-to-one. It has an inverse. Now, let's look at the squaring function. It looks like this. Is it one-to-one? No. So, no inverse. Now, if you remember 30 minutes ago, I started off by showing you that this function had an inverse on a graph. But remember, I only did half of it. That's why I restricted it to one side. Now, no matter what I draw my horizontal line, this one is one-to-one, and it has an inverse. So when people are trying to find inverses, they restrict it to just a region where your function is one-to-one. Then they can find the inverse. That's the whole point. Otherwise, you don't know what the inverse is. If you have these 2 points right here that come from the same x value, if you interchange, so maybe this is -1, and this is 1, and then this is 1. So you have the point -1, 1, and you have the point 1, 1. If you interchange, it's unfortunate I chose 1. Let me choose a 2. That will give you a 4. If you interchange this, you get a 4 minus 2, and you would have a 4, 2. Notice that you have 2 beginning points that stays the same. That means it's not a function. In other words, if you rotated this and flipped this across your line y equals to x, you would have that graph right there. It fails your vertical line test. So you can't take an inverse if it fails your horizontal line test. It has to pass a horizontal line test to have an inverse. You will have a question on the test that's going to ask you if the function has an inverse. I will give you the graph. You simply have to do the horizontal line test. So the horizontal line test is going to be on the test. It's a test question. Again, another easy test question. Can you draw a horizontal line and determine if it crosses your function more than once? If it does, you're just going to tell me there's no inverse. Let's do some examples. Question? They are. Okay, are the functions shown in the following graphs one-to-one? Do they have inverses? So look at them. This right here looks like it's a horizontal line, but it really isn't a horizontal line. It's just because my scale is more spread out across the x's than it is across the y's. So it looks like a horizontal line, but it is not. So this one has an inverse. It passes a horizontal line test. Tell me about the second one. Yeah, no inverse. Test question, just like that. We like those. Steps to find the inverses, and then we'll actually do the algebra. Use a horizontal line test to decide whether f has an inverse or not. You don't want to do all the work if it doesn't have an inverse. Then write f of x by y, replace it by y, interchange x and y, solve for y, write y as f inverse, and you have your answer. Okay. The rest of it is just verifying that you actually did your work correctly. So let's actually do example 7. The instructions in the homework had different parts to it, so I listed all the parts up here. Part A says find the inverse function for f of x. So that means the first step was write y for f of x. So we have y equals the square root of 2x minus 3. The second step was to interchange x and y. Solve that for y. So how do I get y by itself? What should we do first? Square. So I get x squared is equal to, those cancel, 2y minus 3. Then what should we do? Add 3. So we get x squared plus 3 is equal to 2y. Then what? Divided by 2. So we get y is equal to x squared plus 3 over 2. And then the last step is to replace that with f inverse of x. There's our inverse. I told you, it's very simple algebra. When you're done, when you actually get to solving these, it's very straightforward. Not hard at all. That's part A. Part B says graph both f and f inverse on the same set of coordinate axes. So we just have to graph one of them. The other one will be the inverse of it. It will be the line, the reflection across the line y equals to x. It doesn't matter which one we choose to graph. So I'm going to actually graph the first one. I'm going to make a table for this one. The reason is it has that stretch happening right there, that 2. And as we saw last time, I really don't like dealing with what did that actually do with my function. I know I've got a shift of 3 here that's going to the right in there, and I know the shape is a square root shape. So I'm just going to plug in some values here. I need to choose the values, so let me find my domain. Add 3 to both sides, and I have 2x is greater than or equal to 3. X is greater than or equal to 3 halves. So I'm going to plug in 3 halves for the first value so that I know what's happening. And then I'm going to plug in 2 because that's a whole number bigger than 3 halves, which is what it says to do. So let's plug it in. What happens to the 2's right here? They're going to cancel. That's exactly correct. And so then that gives you a 3 minus 3. What is 3 minus 3? 0. Square root of 0 is 0. So we get 3 halves 0. And then let's plug in 2. What is 2 times 2? Minus 3. Square root of 1? 1. So I have, here's 1, here's 2, and here's 1. I'm going to have 2, 1, and then 3 halves is the same as 1.5. It's a square root function, so it looks something like that. Across my line y equals to x, which should be something like that. What is that reflection going to look like? This is our f of x. So f inverse, that 3/2 0 becomes 0 3/2, and that 2 1 becomes 1 2. And it looks something like that. Question?
So they don't always have to match f and x, right?
They don't have to, but if they do, they will always touch on that one.
But they don't always.
They don't have to at all. That's correct. Yeah, this one, they're not going to cross at all.
So the purpose of the line is just a reference to how
to
the flip will
reflect it.
happen.
That's why I put it there. Otherwise, my sketch won't even be close. I need to see that visually. Okay, part C. Very simple. It says describe the relationship between f and f inverse. It's always going to be the same answer. F is the reflection. F inverse is the reflection of f across the line y equals to x. That answer will always stay the same. Doesn't change. And then part D says state the domain and range of f and f inverse. So let's write down the domain of f. We found that right here. It's going to be 3/2 to infinity. And that's also equal to the range of f inverse. Remember, the domain of f is the range of f inverse. What is the range of f? It's the domain of f inverse. That's correct. Now, you could go find your domain for f inverse, or you can go up here and look at your range of f. Your range of f starts at 0, and it's going to go to infinity. So a lot of cutting and pasting on your homework here. Once you figure out the domain for f, you can find the range for f inverse, and vice versa. I would find your domain and range for your f function and use that. Just cut and paste for your f inverse. It's usually the easiest way to go about it. Any questions on that? Alrighty. Oh, did I get that gone too fast? No? Okay. Then this is like a homework problem. Does the function f of x equal x minus 9 squared plus 1 for x greater than or equal to 9 have an inverse? That's the answer I want first. Is your automatic answer is no, it has a square. It can't have an inverse. But notice I said for x greater than or equal to 9. It's only one side. That's exactly right. Tell me about this minus 9 inside here. From yesterday, what is that doing to your function?
Shifts.
Yeah, shifts right 9. So this would, if this was 9 right here, it'd be shifted right 9. And what does that plus 1 do? 1 up. So it goes right here, and it's the right side of it. We have the graph sketched. Does it have an inverse? Has an inverse. Now, let's find the inverse. So that means I have to write it. Y is equal to x minus 9 squared plus 1. Interchange x and y. So x is equal to y minus 9 squared plus 1. Subtract the 1. Now what should I do? How about square root to get rid of that square? Which means I need a plus or minus. That square and that square root are going to go away. Add that 9 to both sides. So we get y is equal to 9 plus or minus the square root of x minus 1. That sure looks like it's not going to be a function. It's got that plus or minus going on. But remember, these are positive y's. So I have to choose the positive symbol because we're restricting it to bigger than, we're going for these x values, which means we're using those y values. It has to be positive. So that means I choose the y equals to 9 plus the square root of x minus 1, and that becomes my f inverse. Tricky on that one. I am not going to assign you one like that for the test. It will be something straightforward and easy. You won't have square roots, and you won't have to take the square root of both sides for it. You won't have an even root on it.
How'd you graph it?
This one? Okay, so this minus 1 is a shift right 1 for your square root, right? And this right here is a shift up 9. So it's going to be right 1, up 9. And it looks like that. In other words, if you were, it would be, oh boy, something like that. These should intersect though. You could tell I'm not an artist, but it would be that reflection across your line like this X. Can we do that on the homework?
Sort of.
Sort of. Okay, you get to try one. Actually, let's just do the homework. Let's go straight to the homework. I want us to get the homework done, and it's already 9:20. So go straight to the homework, skip that checkpoint number 2. Which means you can make sure your names are on those papers, and I can take them from you. Makes it really easy to read this when I've already looked at them for everybody. be right back. Okay, so over here, they're just wanting you to plug in your G of X right here, so you literally just copy that down there. And then you simplify it, you should just get X. And down here, literally, you're gonna copy F down, and then you're gonna type X.
Or here you just put right there.
Yep.
You don't plug it in.
No, they're asking you, this is G of, and then you just copy the F equation down and put right there.
And then from there, do you
And
plug it in and then
then
figure
you
out X?
figure it out to figure out what your answer is gonna be after you simplify it.
But when you're figuring out, do you plug it in?
You're not gonna type in anything over there, you're gonna do that part on your paper. You're gonna plug it in on your paper.
But you know how you plug it? Oh, okay.
You're gonna do that on your paper. Yeah, they're just giving you a space to try and get you to tell them what to plug in. Yeah, I'll do that. Yeah. Mhm. Let me pop it up on WebAssign, I'll show everybody what's going on here. Because they're asking you to do 2 function compositions. Oh, I forgot to stop the recorder.